Okay, so when trying to find a solution for making these blades and cabin assemblies, we've discovered that going in different directions is problematic, so we've decided upon this jig here, which only goes from one side to the other. So when you see here how an operator would have to fumble between parts just to complete the assembly, it just takes too long. Whereas using this jig and practicing 5S and visual controls, an operator can easily just get it done. So this is how stuff goes together with these lean manufacturing jigs. See, things run a lot more smoothly.
Our supplier sucks.
Our supplier does suck. We get a huge pile of parts currently. As you can see, they're all mixed up in different sizes or the same colors, and that's just not ideal for a lean factory. We would like to see our supplier ship our parts in tubes, similar to ICs in the electronics industry. This allows us to have our parts conveniently organized as well as color-coded right when they come in the door. We don't have to hire somebody to sort this mess. So using the trays that we just developed, we can now go directly from sorted parts to sorting these trays without having to go over to this pile and search for parts that are the right color.
If we had these 5S improvements, we could cut time by about half.
Yeah.
Our supplier sucks.
Now we're going to explain the assembly process. We've told you how these trays significantly lower our takt times, but you still might be asking the question, how does that lower your takt time if somebody still has to load the tray, right? So in order to solve this problem, we have made the takt times align. We have 3 sub-assemblers. One assembler assembles the body, the tail, and the propeller section. These sub-assemblies are assembled from the sorted parts given to us by our supplier. And they are built without trays. So every time a sub-assembly is finished, it is handed over to the finished assembler, and he will build the helicopter from these 3 sub-assemblies into a complete helicopter. When he is done with that, he will fill a tray and pass it to one of the sub-assemblers. And every time this cycle repeats, he will build a different tray because there are 3 different sub-assemblies. And now we will demonstrate this to you shortly. So imagine that I have just completed my body sub-assembly and I am passing it off to the finished assembly. Assemble that. At the same time he assembles the finished assembly, I am assembling one without a tray. And the takt times line up so that when this assembly is done, my next tray is given to me. So I would go on to assemble my tray while he is assembling the 3 sub-assemblies that have appeared over here while he was filling that tray.